On this episode, we're going to focus on the enemy AI. So to start off, we could just clone our paddle and give it a positive 11 or a positive whatever number you have already. And that'll put it right on the other side. And there's not going to be much change that we need to do. Well, I'll just call it something else though. I'm going to call it the right paddle. And the other one, I'll just call it the left paddle. So we're not calling it anything like enemy paddle or AI paddle because we want to use the same script for players and for the AI. I think it'll just be a lot easier. So let's go into the paddle script. So the first thing I want to do here is create a public bool that will say, is this an AI? So just is AI. By default it's going to be false, but we're going to change that in the inspector. And for this target position here, what we're going to do is give it a different, we're going to create a method that's going to return a target position. So we're just going to call it first a float, and we'll call it get new Y position. So this, and here we're going to separate our logic between AI code and player movement code. We're going to say if is AI, and we're going to do our AI calculations, else, so if it's not AI, then we're going to return it this here, that we already have. So we're going to do return and that same code. Now you notice that we need to get that movement variable in there. So just up top, I'll put it right there because we only really need it there. We're not going to be using it anywhere else. Alright, so that's returning, and it's giving us an error because if it is AI, it's got nothing to return. Before we do that, let's go in here into the target Y position and let's set it to that get new Y position. And the way our AI is going to work basically is it's going to check the ball's Y position and move accordingly. It's going to pretty much just track the ball in the Y direction only. So if it's going up here, the paddle is going to be tracking only the Y. So what we need is a reference to the ball and to be able to access it in our code. So we could just go down here and create a private ball. We'll just call it ball. And we're going to create or do a start method, and in there we're going to say ball is equal to game object dot find game object with tag. And there we're going to just feed in a ball string, and we want to get the ball component from there, so we do get component ball. Now let's make sure that our ball does have that tag. So go on to your ball, in tags, add tag, and do ball, and make sure we go back and assign it that tag. And we should be able to get our ball because it's going to be the only ball in the whole game. So down here we're just going to return the position if it was tracking the ball. So mathf has a really nice function. So first we're going to return the value we want, and that's going to be in mathf. It's going to be move towards. So it's going to be moving our transform dot position dot y into our balls transform dot position dot y, and that's going to be tracking it. And then if we give it a max delta, which could just be our move speed because that's what we want the max movement to be. So it all works out pretty good, and let's just try it out and see what happens. And we got to make sure that we set that right paddle to is AI. So as you can see, it's pretty much tracking the ball. But to fix that little weird bouncing behavior real quick, I'm going to go into the ball script, and in bounce I'm going to set this into new vector 2, and we could give it the same velocity that it already has for the X, but we're going to give it a negative Y velocity. So now let's run that and see if that issue's fixed. Alright, as you can see, the paddle is effectively tracking our ball. And it has a max speed, so it can't track faster than we can move to make the game fair. So the paddle is moving at the same rate as we can. And to make it a bit more interesting, you could increase the speed of the ball. So I'm going to set that to something like 20. And it looks like we could still move pretty fast enough at least to catch up to the ball, and this is probably going to be an impossible game to beat. So I'm going to lower down our paddle's speed. And actually, before we do that, to make this a lot easier on ourselves, I'm just going to prefab this. I'm just going to call it paddle for now, but you'll see why. And I'm going to create a new folder, call it prefabs, and drag that in there. And now I'm just going to change it back to left paddle, and I'll get rid of this one real quick and duplicate this one again, and then we'll call it right paddle. And then if we move it back here to where it was before and just set that to is AI, if we set the move speed on here on our prefab, so let's say 12, and then go back, that changes it on all of them, so you don't have to change the value on every instance. So let's play again, and you can mess around with these values to make sure that the game is beatable. You don't want an AI that's going to be impossible to beat. So one thing that I want to do is make sure the paddle is only tracking the ball if it's coming towards its direction, right? So if it's only coming towards the paddle, then it can move, right? If it's going this way, I don't see a point for it to be tracking the ball. So let's take a look at how we're going to do that. So down here in our paddle script, I'm going to create a method that returns a bool that will be true if the paddle is incoming. So we're going to call it ball incoming. So this requires a couple things. One is the direction of the ball, and two, the direction that the paddle is facing. So let's look at how we could check what direction we're facing. So I'm going to create a private vector2, and I'm going to call it forward direction. And in start, I'm going to say, well, actually, we need to find a way to know which paddle we are, right? If we're the left paddle or the right paddle. So I'm going to make an enum. I'm going to do public enum, and I'm going to call it side. And we open up brackets, and we could be either the left side or the right side. And if you've never used an enum before, it's pretty much like a label. You kind of like label what we are, so we could be either the left or the right paddle or side in this case. And now that we have what defines our side, we're gonna create a public side, or actually this is gonna be a serialized field. I'm gonna do private side, so that's the enum we just created, and we're just gonna do side in lowercase s. And we could set this in our inspector. So for the left paddle, oh, it's giving us a problem. So I'm going to comment this out real quick. And so in our inspector, we're going to set the left paddle to the left side and the right paddle to the right side. So now we know which paddle is which and what side they're located in. So we could set our forward vector. I'm going to uncomment this and go back up here. So in start, what we're going to do is say if side is equal to side dot left, our forward direction. So if you could imagine, if we're on the left side, we're facing a vector 2 of 1, 0, right? Because that's our forward direction. So we're going to say forward direction is equal to new vector 2, Well, actually, vector already has, or the vector2 struct already has something that's vector2 dot right. And if you can see, this gives us what we want, which is 1 on the x and 0 on the y, because we're not really facing anywhere towards the y. So now we're going to say else if our side is equal to side dot right, then our forward direction would be vector2 dot left. So that's where we're facing, right? If we're on the right side, but we're facing towards the left. That's where we're looking at, right? That's where our ball is coming from. So now we have our forward direction defined. So the way we'll figure out if the ball is coming towards us is we're going to use something called the dot product. And I'll go over it really quick. So here in the documentation, you can see what the vector2 dot method does. And if you can see, it says for normalized vectors, dot returns 1 if they point in exactly the same direction, and -1 if they point in completely opposite direction. So to illustrate that, let's see here. So we have, let's say, 2 vectors going that way. So if they point in the same direction, we're gonna get 1, the number 1 out of this, right? But if they point in the opposite direction, we're going to get -1. So what we're going to do is compare the direction of our ball. So let's say it's coming this way, and our facing direction, which is our forward direction from our paddle, which is that way. So if we get -1, we know that the ball is indeed coming our way, and that's when we can move our paddle. Now to implement this, one thing we'll need from the ball is the direction it's going, which we could access with this velocity variable. But right now, since it's a private variable, we can't really access it. So what we're going to do is create a property out of this. So it looks a little something like this. So after the name of our value, we're going to do a curly bracket, and we're going to do the get keyword, and this means that if we access it from anywhere else, we're allowed to get this value, but we are not allowed to set it. So we do a private set, which means only this class is allowed to set this particular value. Then we got to do a semicolon and then another bracket. And it's giving us a little error right here because it has to be a public variable. So now we're only allowed to set this velocity value inside this class. So no other class, even our paddle class, can't mess with that. And that's pretty much what we want. We want to be able to access it, but we don't want anybody to be able to, or by anyone I mean any other class, to be able to change that value. So here all we need really is we're going to create that dot product. I'm going to call it dot p, and it's going to be equal to our vector2 dot, and we're going to give it our ball dot velocity, and then we're going to give it our forward direction. Now we want to know is if our dot product is positive or negative, and if it's negative, that means that the ball is incoming. So we could return dot p is less than 0. Then we know that the ball is incoming. And I hope you can see that this way of checking what direction the ball is can help us in the case that the paddle is on this side, right? And the ball is coming this way. The alternative way to check this is if the paddle is on one side, we gotta compare the x values with the ball's x value and see which one's greater and which one's less, and it becomes more of a hassle to make that check as opposed to just checking, you know, for the dot product. And I hope you could use the dot product in your future projects. And if you got anything out of this video, I really hope it's that you learn how to use the dot product, because it's really helpful with figuring out directions and stuff like that. So now let's implement this ball incoming method. And to do that, what I'm going to do is above everything, I'm going to create a float, and I'm going to call it result. This is the variable we're going to want to return. But let's say for some reason none of this gives, you know, result value. We want our new position to just be our current position, so we're just going to do transform.position.y. So if all fails, you know, just going to set it back to its transform.position.y. It's not going to move anywhere, as opposed to if we set it to 0, that will glitch our paddle into the 0 position, and we wouldn't want that. It'd look like a glitch, right? So we're going to do, instead of returning right away, we're going to do result is equal to, you know, what we did here, and same for here. We're gonna do result is equal to the rest of this, right? And at the end of everything, we want to return that result. So in the case here that we say if ball incoming, so if it wasn't incoming, we wouldn't have returned anything, right? But since we did set this to its own position, it's going to be returning its own position. So I hope that makes sense, and let's go check that out and see what that looks like. Make sure to save whatever you did on the ball script as well. That way everything compiles. Alright, now let's take a look at what that looks like. As you can see, it's tracking along. Now there is something going on with the paddle right here, and I think I know why it's doing that. So in the move towards, we gotta make sure that that move speed is multiplied by time.delta time, and it should be working now properly, and it's not gonna be exceeding our max move speed. So as you can see, it moves as fast as like we can move. So now there's no more jittering. Let's see if we could try to score on the, well, and we're gonna be fixing some of that stuff in the coming episodes. Yeah, we just play around with the ball's move speed and also the player's move speed to make the game, you know, winnable, right? So I'm gonna try 10 and see what happens.